Designing Finite Automata by Professor D.D. Kadam. Before starting that, we'll see how to design finite automata. What are the prerequisites or what are the things we're supposed to consider? Suppose that you are given some language and wanted to design finite automata that recognize it. Pretending to be an automaton, you receive an input symbols and must determine whether it is a member of a language the automaton is supposed to be recognized. If you get to see number of symbols in the string one by one, after each symbol you must decide whether the string seen so far is a language or not. So how to do that? First, in order to make the decision, you have to figure out what you need to remember about the string as you are reading it. So we have to think which important parameters or what are the things need to be remembered, because we are using finite automata which doesn't have much memory. It is a finite, right? Fortunately, many languages you don't need to remember the entire input. You need to remember certain information which depends upon particular language. That means language to language it differs. So let's start. Suppose that alphabet set is a 0, 1 and that language consists of all strings with odd number of ones. This is what the example we will see how to design the finite automata for this example or in this case. First step is to pretend has to be automaton. So pretending to be automaton, you start getting the inputs. Now inputs here our alphabet set is a 0, 1. So inputs may be zeros and ones, symbol by symbol. Now second step we need to remember the particular string, right? So in this case what you are supposed to remember? Now need to remember whether the number of ones seen so far is even or odd, and keep the track of this information as you read new symbol. So if you read 1, flip the answer, but if you read 0, leave the answer as it is. Why this is so? Because our target is to find out the odd number of ones. Now while doing so, first we say that pretend to be as an automaton. Second, remember some part or you should remember the string. So next step after that, how many states are there? So we need to find out what are the state transition function, right? So identification of the states. After determining the necessary information to remember about the string, it is being read, you represent the information as finite list of possibilities. In this instance, possibilities would be even so far or odd so far, whatever the numbers we have seen. Now we will get zeros and ones symbol by symbol. So in this case, important things or possibility maybe even number of zeros and even number so far and odd number so far. We are talking about the only ones. After that, assign the state to each of the possibilities. So here these are the two possibilities. That's why there are the two states, Q even, Q odd. Now, which one is the start state and which one will this end state? Prior to that, finalizing that, we'll see transition function. When I'm in the Q even, how I will switch to the Q odd, or whenever I'm in the Q odd, when to switch back to the even. So next, assign the transition by seeing how to go from one possibility to another upon reading a symbol. So if state Q even represent even possibility and state Q odd represent odd possibility, you would state the transition to flip the state on 1. and on 1 we will change the state, and stay now put on this 0 as shown here. Means what? Whenever I'm in the queue even, if I see 0 I will be in the queue even, but whenever I see 1 I will switch to queue odd. Again same rule. If I'm in the queue odd and I see 0, I will be in the same state. And once I get the 1, I will go back to the queue even. Now this is the trace transition. But where to start? Which out of these two states? Which one is the start state and which one is the final state? How I will conclude that? So after doing that, next part is adding start state and the accepting state or the final state. The start state is to be the state corresponding to the possibility associated with having seen 0 symbols so far. That means initial state, nothing I have seen yet. In this state, start corresponds to queue even because 0 is an even number. Set the accept state to be those corresponds to the possibilities where you want to accept the input string. In our case, set queue odd to be an accept because you want to accept when you have seen odd number of ones. This is what expected thing. This is what we want to achieve. Whatever the string containing odd number of ones, only that is to be accepted. So this will be the our accepting state. Now, so this is how we are going to conclude. So final design will look like for the problem statement. What was the problem statement? Earlier we said find the language consisting of all strings with odd number of ones, and alphabet set is 0 and 1. So we can define the language, define the finite automata in the form of tuple, or we can represent it in the graphical or tabular form. We can say here the transition graph, because we can draw the transition matrix from this. Once you know the states, once you know the symbols, input symbols, rows will be the state, column will be the input symbol. And which one is the input state? The which is pointed by the arrow. Which one is the last state in the matrix? Which is pointed by the star. So that is we already have seen. So just we can define the finite automata with the help of transition graph like this. So in this case, queue even is the start state. On reading 0, you will be in the queue even. Once I get the first one, that is the accepting state. And if after 1 any number of zeros comes, still it contains the odd number of ones, so it is accepted. But if we get one more 1 in the queue odd state, we will go back to the queue even. So it will be containing 2 ones, which is even, which is not expected. So we are going to the non-accepting state, that is the queue even. Again, if you get 1, then it is accepted as it contains the 3 ones, right? References from these 2 books. So what we have studied in today's lecture, how to design a finite automata.